I'm from America, by the way, so it's kind of ironic that I'm, coming from the United States and talking to you about how to save the world, but that's a whole other conversation. So I think a couple of things I want to kind of run through. One of the things that's really important, I think, to consider, and this is kind of our tagline of our foundation, is connecting AI to the real world, right? At the end of the day, if it's just, chatbots and fake girlfriends and unicorn poems and cool things like that, that's not the real world. The real world is, water systems, power grids, agriculture, restaurants, retail, industrial manufacturing. And AI really requires the edge to have an impact in the real world. It's something that we always consider and try to figure out how to really make it happen. So, in as much as we see, the AI that's kind of publicly available and people are interacting with, the stuff that maybe you don't see that's embedded in the systems around you is really having a much more of an impact on what's happening out there. I think the other thing to think about is the frontier right now for AI is efficiency. We're kind of at the steam engine version of AI these days, very inefficient. If you think about it, the kind of a fully functioning human brain is about 25 watts, fully functioning. If you had some sort of AGI data center, that would be like 25 gigawatts, right? So we are orders of magnitude away from real efficiency in AI. And so anyone out there that is optimizing, pruning, quantizing, sparsityizing AI to make it fit and work in the real world, that's really where the efficiency is and where the frontier is. And in fact, if you look at even situations like DeepSeek and other releases out there, it really kind of shakes up the status quo and people are able to create new efficiencies around AI. So I think definitely in the next 5 years, the frontier is around efficiency. The other thing to think about too, I think the AWS person said it best, it's not cloud versus edge, right? It's cloud and edge working together. It's a continuum of workloads from the cloud to the edge. And that cloud could be near-prem, could be a neo-cloud, it could be on-prem, but you really need to think about these things together. First of all, we certainly need the cloud for the foreseeable future to do the heavy-duty training. Building out these data centers, I saw Microsoft just announced a new data center. I worked at Microsoft for 18 years. Big fan. Not a huge fan of like gigantic data centers, but if you're going to have them, you might as well use them for training massive data sets. And I think as they mentioned before too, is like pretty much every deployment out there, even though we may be processing at the edge, still requires the cloud. But the interesting thing about it, the real winners in this space will be ones that think of these things as a holistic solution and use cloud-native techniques to manage the entire system. And I'll talk a little bit about that later, but if you think about ML ops and orchestration, ideally you want to look at your whole system from cloud to edge as kind of one set of resources. One of the kind of big issues, though, is really this, I would call it the sustainability cliff. I probably don't need to sell an audience full of kind of low-power enthusiasts and edge enthusiasts about kind of the issues around building more and more massive data centers. Someone asked me earlier, I think David asked me, who to invest in the future, and I said anyone who's making small nuclear reactors for hyperscalers, because every big data center moving forward will either be behind the grid or have its own nuclear power plant connected to it. But right now there is a sustainability cliff. There's just too much water being used, too much electricity, too much sound. Actually, I didn't realize this, but I'd read that the decibel level for a lot of data centers is in the 90 decibel range, 92 to 96 dB, which is incredibly loud. And so I think at some point there's going to be a factor where the return on investment for massive data centers, we're going to have to think about how else can we execute our AI, especially in the real world, without requiring this kind of data center investment. It'll be happening for a long time, trust me, for many, many years, but there will be an asymptote. So all this really points to edge AI to the rescue. And again, I'm a little biased. I'll talk a little bit about the foundation at the end. But when people talk about edge AI, there's this term called BLERP, B-L-E-R-P, that a lot of people use to sort of figure out why to use edge AI. Bandwidth and latency, the economics, the cost, the reliability of the data, the privacy of the data, security. That's called BLERP. So we talk about bringing your data to the AI. Instead of doing that, you want to run your AI to the data. So you want to run your AI workloads as close to where the data is created as possible, and that's where you get the lowest cost and the highest impact. So by the numbers, I'll just run through this quickly. One of the interesting data points you probably heard from Gartner is that 75% of all data is created on the edge, right? So then you would say, oh, well, probably the default position should be to run the AI workloads on the edge where the data is created. Now, I don't think I'm going to make a claim that 75% of AI workloads are running on the edge, but maybe at some point we can flip that and AI on the edge becomes the default position and you use the cloud only when necessary. Lots of big numbers here, but the fact is that this is a high growth area. Pretty much every company here that I've talked to is figuring out how to integrate AI somewhere in their processes and their devices, even into the radio modems themselves. So it's a super exciting place to be. One of the things that I think about too is where are the breakthroughs that are happening over the next 3 to 5 years in edge AI that'll really take this to the next level. If you think about the edge AI community, it's kind of a stack. I call it kind of layers and players. But this is the layer stack. And all of you know what a tech stack looks like, but I think of it from metal to cloud, from silicon IP to solution providers. And in between, you've got obviously silicon and device builders and devices and middleware and orchestration and clouds. But there's stuff that's happening up and down this stack that you should be aware of. And maybe some of you are working at companies that are doing this already, but it's really going to be a force multiplier for edge AI. So a couple of things that we're keeping an eye on, I would say. First is we're seeing a lot more transformer-based models moving to edge equipment. There's language models, small language models, we'll talk about that, but agentic AI and agentic edge AI, and how do you connect agentic AI systems to the real world, right? Through physical AI, through robotic systems, through actuators. We're going to start to see a lot more of that and a lot more solutions that are leveraging that, which is driving and leveraging a lot of the new silicon out there as well. A lot of interesting work happening in interconnects to connect up all these things. I mentioned before about cloud native orchestration. So as you know, in the IoT space, it's been, I don't want to say the Wild West, but it's been challenging to kind of manage, deploy, provision these devices. We're starting to see a lot more innovation around, I would say, kind of CNCF style, Kubernetes style orchestration of ML ops to the edge. There's a company here called Atom. They don't have a booth, but they're floating around. So they do WASM-based deployment of AI models to MCU level devices and beyond. So I think we're going to start to see companies in this space. Atom is in there. Edge Impulse does some stuff. Zedata, Latent AI, who are really kind of connecting the edge of devices to the cloud in one sort of seamless way. So we think that's a big thing. Crazy small language models. So there's no good terminology here. There's language models. People call them large language models. Sometimes they're small language models. I read this the other day. Someone came up with the term crazy small language models. Maybe they're tiny language models, but millions of parameters or billions of parameters. Typically, a billion parameter model takes up about 1 gig of RAM. That'll get more efficient over time. But we're starting to see these things really become much more prevalent. I mean, they're already running in your phone, but they'll be running in all kinds of equipment in the next 3 years, usually coupled with sensor networks and doing much more contextual and interesting things. One of the other key areas, I think, is around semiconductors. Yes, there's new chips coming out with more tops, tens of tops, maybe hundreds of tops in the edge space, maybe. But what's really interesting is the low power stuff. So there's a company around here that's local called Inotera. That's a neuromorphic based computing. So about what they claim is to be about 10,000 times more power efficient than an MCU in terms of running AI models. So instead of trying to stuff an AI model into a traditional semiconductor architecture like ARM or x86, what if you re-architected the chip to be modeled around the AI model itself? And that's really kind of the idea behind neuromorphic and spiking neural networks. So we're going to start to see things that can be peel and stick deployed that have battery life that is, I wouldn't say infinite, but many, many years. And I think that's going to be a big game changer as well. So a path forward, just a couple of things. 4 key investments. I would encourage everyone to think about these things. How do we advance the science and technology? First of all, this is still a very research-driven industry. The academic research is really critical and needs to be commercialized. Secondly, we talk about empowerment through knowledge. We need to share the knowledge with each other. I was talking to one of my colleagues in academia earlier, and what's really great about academia is they love to share the knowledge. And in this kind of space, we need to educate each other and work together collaboratively. Building these deeper partnerships. I mentioned the stack before. I think if you looked at that stack, you could probably find yourself in one of those layers. In order for a Chevron or a Domino's Pizza or whoever to actually deploy this stuff, we need to work together collaboratively. And then finally, investing in this global ecosystem. So really, that's what the Edge AI Foundation's about. We consider ourselves to be the world's largest community of developers, Edge AI developers, technology providers, and academia. We're a nonprofit. I have about 100 companies and universities involved. I have about 1 million views on YouTube. You should subscribe to our channel. We have live streams there all the time. Sometimes it's PhDs presenting their stuff. Sometimes it's chip companies talking about their new chips, but it's all about empowerment through knowledge. We have lots of students. We have a scholarship fund where we underwrite curriculum around the world in educational programs. And then we have events. So, part of the reason why we have Edge AI here is that Vinky and I, probably about 6 months ago, talked about how do we bring the Edge AI community into this community and start, cross-pollinating. But we have our own events as well. We have one coming up in Taipei, November 11th. It's a 2-day event. We were in Milan in July for 3 days. So we do lots of things together to kind of bring this community forward. So I would conclude with this. Basically, we see this world happening with Edge AI. We see that we're on the cusp of a lot of amazing breakthroughs in research. But it's only going to happen if we work together and we collaborate, take some lessons from academia about sharing information and empowering others through knowledge, and then just working together for this transformation. So, and hopefully that will change the world. That's about it. Cool. Before I go, one of the things we're doing here that's kind of fun is we're doing a scavenger hunt. So if you QR code that thing and put that code in there, you'll be asked to do certain things out there and take pictures, and you'll win some cool prizes. We have a new Edge AI Foundation coffee mug that you can win if you go do that. So if you download the app, it'll take you through some cool missions, and you'll be able to do all sorts of cool stuff. Great. That's my talk. Thanks.